Hello. So today we will be understanding regarding eigenvalues and eigenvectors basically. Suppose you are having a matrix which I have shown you over here. So any matrix of the form, this is the matrix or 3 cross 3 matrix I've written over here. This is my 3 cross 3 matrix. Here I represents the number of rows whereas the J represents the number of columns. So n cross n. So here the number of rows are 3 and the number of columns are 3. Now we similarly have an identity matrix. Only you will notice the diagonal elements are 1, 1 and the off diagonal elements are 0, 0. As the matrix progresses, like for example for 2 cross 2, 1, 1, and you can see for 3 cross 3 only the diagonal elements are 1 and 1. So whenever we are having any eigenvalue problem of this form ax and lambda x, we'll be using a characteristic equation a minus lambda I. So if I'm multiplying just by this lambda here, so lambda I value will become lambda into 1, rest all values are becoming 0. So this is 0, 0, 0, here also 0 and lambda. And if I have to just subtract this, so the value of this matrix you can notice would be A11. Only the diagonal elements are getting subtracted by lambda. So we get this concept over here. Now the beauty of the GATE exam is that they are always asking the problem that are associated with this concept. So this concept is very important. So this is called the eigenvalue. Now suppose for example, if you are having a normal lambda 1, lambda 2, lambda n are the eigenvalues for the matrix. Suppose you are having A. Now for A inverse, these values will become 1 by lambda 1, 1 by lambda 2, 1 by lambda n. Now suppose if you are having a matrix of the order of let's say A to the power k, then your these vectors will become equal to lambda 1. If you are having k number of vectors, lambda 2, okay, raised to the power plus lambda k to the power k. So eigenvalues of A is equal to eigenvalues of the A transpose. Transpose means what? Suppose you are having 2, 3, 4, 5. So this is your A value here. A transpose value just change the rows by column. So you write the row in form of column. So this column I have written in form of column or vice versa you do. 3. So 2 and 4 I wrote over there in form of row and 3 and 5 I'll write here. So this becomes my A transpose. Okay. So 2 and 4 in form of row I have changed to column I have changed to row and the second column I have changed to row. And product of eigenvalues will give you the determinant of the matrix and maximum number of eigenvalues is equal to trace of a matrix. Trace basically suppose you are having lambda 1 and lambda 2. So this means the trace of the matrix. Now here if we will see we'll be seeing basically, so we are given a question over here. You can notice just a second, see here. Consider a non-singular 2 cross 2 square matrix A if trace of A is 4. That means lambda 1 plus lambda 2 is equal to 4. That is given in the question. Okay. And trace of A square. A square means what? Lambda 1 square plus lambda 2 square. This is equal to 5. So this is the question that has been given. Then the determinant of the matrix would be equal to. Now already we know that. What is your determinant of the matrix? Determinant of A is the product of this lambda 1 and lambda 2. Okay. So trace of A has been given in the question. Trace of A is lambda 1 plus lambda 2, which is given as 4. And also trace of A square is given, right? A square is given as lambda 1 plus lambda 2 ka lambda 1 square plus lambda 2 square 4. So you just need to solve these equations. Now, if you just use here this trace of A ka whole square, which would be your lambda 1 plus lambda 2 ka whole square. Just expand this so it would be lambda 1 square plus lambda 2 square plus 2 lambda 1 lambda 2. Correct? So lambda 1 and lambda 2 represents the determinant, right? So this would be, this is your trace of A square, right? Is equal to trace of A square. Lambda 1 plus lambda 2 square becomes trace of A square. Okay. This is the difference between that plus 2 determinant of A. Okay. So we just utilize this trace of A square. We do know that this is equal to 4 square because trace of A is given as lambda 1 plus lambda 2, which is 4. So that means trace of A square, what it's going to become? It's going to become 4 square. So this is 16. Again, trace of A square, that is your lambda 1 square plus lambda 2 square, which is given as 5. So that 5 would be equal to twice the determinant of A. Now, if you calculate this 16 minus 5, 11, and determinant of A would be 11 divided by 2, 5.5. Straight away, you can use this formula also in this to solve. Trace of a 2 cross 2 matrix is given. Trace of A square is equal to trace of A. Okay. We can say trace of A square plus twice determinant of A. So directly you can write determinant of A is equal to trace of A square minus trace A square. So this is your 16 minus 5 and twice determinant of A. So that is your determinant of A would be equal to divide by 2. So this is the formula. Determinant of A is equal to trace of A square minus trace of A ka whole square divided by 2. If you just put in this formula in 1 second, you will get the answer 5.5. Now one more question was asked in GATE 2024. So here you see the sum of the eigenvalues of the matrix. Now matrix is given, A is given as 1, 2, 3 and 4. So in this question, what do you require? In this question, we'll be requiring to multiply the basically the matrix we need to multiply here. So the question that is being given here is A is equal to 1, 3, 2, 4 ka whole square. So squaring this term 1, 2, 3, 4 you write down. 1, 2, 3, 4 you write down. Just multiply. Just take these rows and this column. So first row and first column. So this would be 1 into 1. Okay. Plus 2 into 3. Then for this first row and second column. So 1 into 2 plus 3 into. So see this 1 into 2 plus 1 into 2 plus 3 into 4. 3 into 4. This is the value of this you are getting A square, right? Same way for the second one. So this would be 2 into 1 plus 4 into 3. And this would be 2 into q plus 4 into 4. Okay. So you just calculate this would be 7. This is going to be 12 and how much is that value? 12 plus, yeah, 12 plus 2, 14. Okay. And the below value, if you are going to calculate, that is 2 plus 4, 14 again. So you get these values and just trace. He has asked the question in this question. What he is asking? He's asking for the trace, right? So if you just look here, yeah, whether I'm doing correctly, one, okay. So this is 1, 2, 3, 4, right? 1, 2, 3, 4, and again 1, 2, 3, 4. So the first value I've done 1 into 1 plus 2 into 3, that is correct. So that is giving me a 7 value. The second value would be the second column, right? First row and the second column here. 1 into 3 and 1, okay. 1, okay. So if I, just a second, yeah, what I'm doing. Just one sec. Yeah, okay, so I have to expand this. So one sec. So this is 1, 3, 2, 4. Again, this is 1, 3, 2, 4. So the first value is, if we take the first column, then we should take the first row. So that is 1 into 1 plus 2 into 3. Then for this first column, second row, 1 into 3 plus 1 into 3 plus 3 into 4. 1, 1 into 3, correct? Plus, so this column you are taking, okay, into 4, then 2 into 1 plus what is happening here? 1 to 1 plus 2 into 1 done, 21 is done, then over to 4, 4 into then 2 2 into 3 plus 4 into 4. So this is the value. So this is giving 7. This is giving 12 plus 3, 15, correct? 15. And this is giving 8 plus 2, 10. And this is giving me 2, 6. And this is 14. No, 16. 16 plus, yeah, 16 plus 6, 22. Now what is asked? Trace, right? Trace of it. That would be lambda 1 plus lambda 2. So it will straight away 22 plus 7. So this is the value I'm going to get, 29. So we'll be coming up with the other videos also. So I'll stop this here.